Could you please introduce yourself and let us know which institute you're coming from?
So I am Rico Mayro Tanyag. I come from the Technical University of Berlin. I work as a postdoctoral researcher at the group of Thomas Müller.
And how does it feel like being among the first users to have the beam time in this
Well,
run?
it's certainly a privilege to be some of the first users to be allowed to come here, but then at the same time, it's a bit overwhelming because I mean the expectations from the team to make the experiment running is much more concentrated to a few people, and it's not like in an ordinary beam time that it's like you have a lot of people in there. So, but overall, I would say it's a mixed feeling that we're back. Yeah.
And what is so different about accessing the beam time during the COVID restrictions?
Uh, there are about 20 people in our team, and there's only two of us who are allowed on site, and the rest are just online, guiding us, telling us what to do. Especially the PI is actually coming all the way from LA, so there is a time difference of 9 hours. So when we start our beam time, it's actually 11 a.m. in there, and they have to stay up all night. But I mean, again, this is like a night shift for them. So overall, it doesn't change a real beam time situation in terms of like adjusting for time. But what's really a huge difficulty is the communication, because they are communicating online, and there are things that you can communicate in real time easily, but then when you communicate it online, something gets lost, things get stuck, like the sometimes their screen get frozen for some time, or the internet breaks down. So yeah, we have to repeat everything again and again in order to have the ideas come across.
Um, so, in simple words, for a very general audience, how would you describe what you're doing, your experiment?
Okay. We are creating highly charged helium droplets. They are superfluid. And what we're interested at is how this charge affect the shape of the droplet, how they are rotating, and then how the charges are distributed in the droplet. Uh, and then in order for us to see how this charge are distributed in the droplet, we want to put xenon in it. And this creates some contrast in our imaging experiments to see, and then we do some image reconstructions to see the position of xenon. And hopefully it's, they are sitting where it's supposed to sit.
How are the experiments going so far?
Um, for the first 2 days, we were just optimizing conditions to have the experiment running, uh, and making sure that everything is in operation. And then in the past couple of days, yeah, we try to troubleshoot as much as we can. But today we are now on a data collection mode. So things seems to be running okay, and of course we still have to optimize our condition for a maximum data collection, but overall I would say it's going on the right track.
And how do you see research at light sources such as XFELs and synchrotrons developing within the next months?
Well, it's very difficult for me to answer this question because I am mostly using, well, I'm exclusively using X-ray free electron lasers for our research. Um, but on a scientific level, I would say it would not change much. But on a communication level or on a personal level, because beam times are not only scientific, it's also a human communication in a way. And this is a bit lost because you meet friends during beam time, you get to know how to work with the person during beam time, and when you're working with them from afar or online, the interaction seems artificial.